Let's go get it, nerds. Derivatives of a function they're going to create. So you got a function, derivatives are now going to become another function. You might be wondering, what's up with all these functions? What are you talking about? What do you mean function? Derivative of a function. Hey, remember this? The derivative at some point A. It can tell you the slope of the tangent line. It can tell you the instantaneous rate of change at a point. It can tell you the instantaneous velocity. It can tell you all kinds of stuff. But only at a point. At one particular point. What we're going to do now, somebody much smarter than me did back in the day, is they're like, hey, don't just call it some number, A. Let's create a whole new frickin' function. Let's make a whole new function. So maybe for you right now, you're like, we're in the next section now. I don't write A anymore. Now I'm going to write X. Maybe that's what you're going to get from this. Cool. Whatever you need to do. We all get through at our own pace. Sometimes you got to fake it till you make it. You're not going to catch everything I'm saying and every point I'm trying to get across. You take what you can, and then maybe you come back and try and figure it out later. Who am I? I'm not your mom. Let me give you some examples. So let's just go to this one first. For example, a function. F of x. Got one. Right here. F of x. And we can say it's derivative. If you were to take it, plug it inside of here and go and do all that other bullshit, I'll spare you that, all the algebra. It's going to pop out that its derivative is 2x. Notice, it's a whole new function. We know an x squared minus 4, that's a parabola. Facing a 2x, that's just a line. Right? If we were to take this aside and go y equals x squared minus 4, you're like, oh shit, that's a parabola. Y equals 2x. Oh, you mean a line? Alright, no. Cool, it creates a whole new frickin' function. And you know what? You can keep taking derivatives on this crap. I'll do it at the end. I'll just start taking derivatives. Just do it over and over and over and over again until stuff just disappears sometimes. So here's an example. I got another one over there. You might be able to look at it too with sines and cosines. We'll move into that. Just to let you know, the derivative of sine is cosine. Convenient. Not explaining why. No explanations at all. Just, it is. You'll find out more about it, but we'll get to that in a moment. So here is our function. F of x is equal to x squared minus 4. And I have it somewhat graphed, whatever. My graphic sucks. But I think you could probably read it. Now here's how a derivative function works. This is going to model the slope of the tangent line. To f of x. Oh my gosh, that's a mouthful. It's going to model, it's going to show you what's up. So, hold on, let's just start here. There's one place where we always want to look. When we're talking about slopes of tangent lines and derivatives, it's always at peaks and valleys. Let's just go take a look at a peak and a valley. There's no peaks. Shit. I'm talking about our graph. Now I'm going to take all these words out. I want you looking at those words. I want you coming back to this. So screw the derivative, screw any of that stuff we're just looking at, and let's see if we can't find a valley. And it's right down here. Huh? So if we were to create a tangent line, what this would do is it would actually be horizontal, right where you hit a valley or a peak, that we could say that the slope of this tangent line would be equal to 0 there. It's a good base. 0 is our friend. We love frickin' 0. It's how you factor. You set it equal to 0, you factor, and then you can solve for shit. Same thing in calculus. We're going to be doing a lot of this shit where we're going to end up taking a derivative, setting it equal to 0, and solving. That is, shit, that's chapter 4. That's like all of chapter 4. Take a derivative, set it equal to 0, solve. But what this is this is saying the slope of our tangent line is 0. Let me go in with my little ruler thing and show you this. So right here, right? 0 degrees. We have a slope. There's no frickin' slope going on, right? It's just there's no slope. Now, as we start moving, say, this way, maybe we look at a point. Oh, no, that's not the right one. Maybe we get a different tangent line and I draw it like this. And is that a positive slope? Is that a positive slope when we're up like this? Yeah, it is. That's a positive slope. So that means our derivative all has to be positive. F prime of x, that derivative, whatever that frickin' number is, actually I should write F prime of a, but we're going to say it's greater than 0. Anytime we're over on the right-hand side, because the slope of that tangent line is going to be positive. Bear with me. If you're not catching it, just keep holding on. So I'm going to remove this. And just saying that our slope's going to be positive. No big deal. Now let's look off to the left. Now, isn't this slope of the tangent line, anywhere we draw it, like it just draw it in, that's negative, right? That would be a negative slope of the tangent line. But right here, that shit would be positive. I mean, that would be 0. This would be a slope of a tangent line that's equal to 0. Cool. Well, I'm going to draw the derivative in now. I'm just going to draw this derivative in, 2x. Hey, look at that. Look, its height is 0 when the slope of that tangent line is equal to 0. That goes up to 4, goes down to negative 4, so there it goes. And there it goes. There's f prime of x is equal to 2x. That's supposed to be a straight line, so suspension of disbelief. I even have a ruler. I have a ruler. I didn't use it. Tough shit. I don't want to go back. I feel silly. All right, keep going. What this shows is, what's the slope of the tangent line at any given point? What's the slope of the tangent line at any given point? So right here, the slope of the tangent line is 0. And notice the height of your derivative is also 0, telling you what the slope is. As we come over to here, right at x equals 2, we want to find the slope of that tangent line. It's no big deal. We just have to go find the point. Oops. It's supposed to be right there before. We would find out if you plug in 2 into your derivative function, you would get 2 times 2, which was equal to 4. But that's the height. That would be the height of your derivative function. Don't worry, I'm going to take you to Desmos and show you real graphs, not just the bullshit I draw. So, but that's the game. So this is a new function that is actually telling you the slope of the line. Now, whoa, hold up. Isn't the slope of the tangent line negative over here? That's a negative slope. Yeah, no shit. Look at the derivative. The derivative's negative too. Isn't this getting more and more negative? Like that slope's getting more and more, and that, like as we go this way, that's a really negative. Just as our derivative is going towards. Oh, look at that, towards like negative infinity instead of saying, huh. And then we look over on our positive side and go, oh look, that shit's sloping up so steep. That would be so steep, it's approaching infinity steep. Just like this thing's taking off towards infinity. All right, enough of that. I'm just drawing and saying the same shit over and over and over again. Moving on. We go to sine of x, and I will tell you that, hey, cosine of x is its derivative. Let's just jump right in, and we look. Sine of x. Let's look everywhere where the slope of the tangent line would equal 0. Maybe here. Maybe here. Maybe here. Right there. Peaks and valleys, peaks and valleys. That's just all we're looking for here. Peaks and valleys. Sweet. So that would mean when you go to graph cosine, since this is derivative, it would have x-intercepts here, or the height being 0, because it models the slope of the tangent line. Now, if you know how cosine is graphed, it's like this. Comes down, goes up, goes down. There it is. Even if you can't graph like me, you can still kind of draw something. Slope of the tangent line is 0. That's why our function is 0. That's why the derivative function is 0.
Isn't this starting to slope down now? Negative. That's why this is in the negative region. It peaks, it has its most negative slope right here. And you can see because the derivative function also hits the bottom. It continues to slope down, but it's going to start to flatten out. And that's why this is coming back up to 0, saying the slope is starting to flatten out. Now as we start to increase, our derivative starts to increase, saying we're sloping up, hitting our maximum slope right in here. That's why it's peaking out. And we continue on, and now we're going to hit another peak, saying that our slope of the tangent line will be equal to 0, and that's why we're going to touch back down. This is about the best I can do with how these are going to work together. I'm not the best with the graphical, but I think I've done an okay job. Here, we go to something new. It's already graphed Desmos, some sort of function, and then we also have its derivative mapped as well. You can see at the top of the orange lines, right here, at -1, 2, look right below it. Its derivative function is hitting the x-axis. So if you can at least see these pieces for now, just where the slope of the tangent line equals 0 will be the x-intercept of your derivative function, that's dope. That's dope. So what is in orange here is your function. What's in purple represents the derivative. And you're going to have to be able to recognize this shit. Your homework has so much of this crap looking at graphs. I'm forcing you into it. Have fun, y'all. I sucked at that stuff, and I don't think I teach it very well either, so you're welcome for that. Let's look at another one where there's a valley, right? Right in there. There's a valley. We'll look right back up top. Boom. What's up? You see what I'm saying? Or you don't. All right. We'll find derivatives in the next one. I'll stop talking about all the graphs. This is pretty much going to be an exploration on your part to go into Desmos, start graphing stuff, look at derivatives, learn your power rules so you can play the game real fast. You can't use it on a test. No derivatives on tests. You can only, whatever. We'll talk later.